Professor Dave and Chegg here. We know an ether is a functional group whereby an oxygen atom is connected to two separate alkyl groups. But how do we name these, and what are some of their properties? Let's get a closer look at this functional group now.
Once again, ethers are a little bit like alcohols, but whereas an alcohol is ROH, an ether is ROR. So instead of alkyl on just one side of the oxygen atom, we have alkyl on both sides. We have replaced the hydrogen in an alcohol with more alkyl. These alkyl groups can be absolutely anything. They can be the same group or different groups. The convention we have for naming ethers is to simply list the two alkyl groups in alphabetical order, followed by the word ether. So for example, this is ethyl-methyl ether. This is butyl-propyl ether. We could also call them methoxyethane and 1-propoxybutane, with the smaller alkyl fragment becoming part of an alkoxy substituent off of a main chain. If the alkyl groups are the same, which is quite common, we can report them at the same time. This is dimethyl ether. This is diethyl ether. This last one is a common organic solvent. We can look at more complicated alkyl groups as well. This is diisopropyl ether. This is an isopropyl group with propyl for the 3 carbons and the prefix iso for the configuration, as this is not a straight chain, but is connected by the middle carbon. 2 other similar groups include tert-butyl groups and sec-butyl groups, whereby the prefixes tert and sec refer to these carbons, which resemble tertiary or secondary carbons according to the number of other carbons they are attached to within the substituent, either 3 or 2. And of course, there can be larger substituents as well, such as with ethylphenyl ether and so forth. We must also be aware of what occurs when there are other relevant functional groups as well. Once again, when an ether must be listed as a substituent due to the presence of a higher priority substituent, we will refer to the oxygen and one of its alkyl substituents as an alkoxy group. So this is para-dimethoxybenzene, as there are 2 methoxy groups. This is 4-tert-butoxy-1-cyclohexene, since the cyclohexene takes priority. In terms of the properties of ethers, the geometry is quite similar to water, given the sp3 hybridized oxygen atom, but we will have to bear in mind that they are less polar than alcohols, as there is no OH group, which also means they are incapable of hydrogen bonding. Instead, there will be a dipole because of the polarity of carbon-oxygen bonds, but it will be rather weak because of the way the bond-dipole vectors add together, largely canceling out and leaving a small net dipole. This is why we see the large discrepancy in the boiling points of compounds like dimethyl ether and ethanol, which have the same mass, but differing abilities to make electrostatic interactions. However, the boiling points of ethers will be higher than corresponding alkanes, as there is some slight polarity which keeps the molecules sticking together a little better. Ethers tend to be less reactive, as there are no acidic protons or highly polarized bonds. However, ethers can react slowly with oxygen in the air to yield peroxides, which contain an oxygen-oxygen bond.
With that, we have a better understanding of ethers, how to name them, and some of their properties. Professor Dave for Chegg. See you next time.